Friends, welcome to our channel Total Output Power Solutions. I am Manohar Tatsovadi, and in this session we will be starting the PA fan. In our simulator we will be starting the PA fans. So there are two PA fans, PA fan A and PA fan B. These two fans will be starting to get the PA header pressure of 800 millimeters of water column. So let us start with this. We will be talking about some interlocks also. We will be talking about some starting interlocks and some tripping interlocks also. So the starting interlocks for PA fan, they are as below. The PA fan interlocks are when we are yet to start the PA fan. The starting conditions means prior to start is PA fan A and PA fan B both are off. The outlet dampers of PA fan A and PA fan B are closed and they are put on interlock. Regulating damper of fan A and fan B it is in closed position and it is in manual mode. Now this starting interlocks for PA fan A when the PA fan B is off and we are starting PA fan A. So PA fan A shall be prohibited from starting until the following conditions are satisfied. The condition number 1 is regulating damper of PA fan A is in minimum position, outlet damper of fan A it is in closed position, then any one of the FD fans should be on. Purge complete must be there from the FSSS. PA fan and fan motor bearing temperatures they are not very high and no tripping command is there from. Then PA fan lubricating oil pressure is adequate. PA fan selector switch is in A position. Note, the signal from PA fan A start push button shall simultaneously go to PA fan A and seal air fans. Means as when you give the starting command to PA fan, seal air fan will also start. So these are the starting interlocks for the PA fan, PA fan A. When both the PA fans are off and we want to start the PA fan A. So as soon as you start the PA fan A, the push button will be pressed, the seal air fan of PA fan A will start. The starting sequence of PA fan. Now what is the starting sequence of PA fan? When the PA fan B is off, that time the starting of PA fan is started, impulses will be given for opening the outlet damper of PA fan A after the motor reaches the rated speed, then bringing the regulating damper of PA fan B to minimum position, then closing the outlet damper of PA fan B if it is open, then permission to start any 3 mills through FSSS. So the starting of PA fan B when PA fan A is off, the interlocks similar to those for PA fan A, they shall hold good for this condition. After starting the PA fan B, the outlet damper will open on interlock after the PA fan motor reaches the rated speed. That is the same as PA fan A. Well, now the tripping interlocks of PA fan. Now tripping of PA fan, it shall trip under the following conditions. Condition number 1 is PA fan bearing temperature very high. Then PA fan motor bearing temperature very high. On high there will be an alarm, on very high there will be tripping. Now if the boiler trips, the PA fans will trip. Bearing vibrations of fan and motor are very high. In that case you can, if they are high you can manually trip them, or if they are very high the tripping may be provided. When PA fan A trips, impulses shall be given for disconnecting the regulating damper of PA fan A from the auto control. Then bringing the regulating damper of PA fan A to minimum position. Closing the outlet damper of PA fan A. Bringing the regulating damper of PA fan B to minimum position if fan B is off. Then closing the outlet damper of PA fan B if fan B is off. Then tripping all the operating mills. It will be done through the FSSS if fan B is off. Then tripping of PA fan if PA fan B if PA fan A is off. The interlock similar to the above for PA fan A shall hold good for this condition. Now we will establish the primary airflow. So establishing the primary airflow, that is the starting of primary air fans A and B. So check the lube oil pump trial for standby pump auto pickup for both the fans from the control desk 1. You can start the lube oil pumps put it on auto, trip, and you should see that the second pump starts. Check the seal air fans on auto mode and they are off. Check the PA flow dampers of APH inlet and outlet on field page number 2, item number 12, 13, 14 and 15, that is AD 40, 41 and AD 20, 21. Open the cold air gates of all coal mills ready, those coal mills which are ready. Open the cold air damper of the coal mill that is to be taken in service. Now go to the control desk 1 and put the seal air fans on interlock. Check the selector switch for PA fans on A if PA fan A is to be started. Check for the PA fan A vanes position to 0. Discharge damper of both the fans closed and they are on interlock. Interconnecting dampers are also on interlock. Check the set point of PA header pressure at 800 mm of water column. Well, this is the circuit diagram of PA fans and associated dampers in cold and hot air primary air circuit. Now here in this circuit you will see that the PA fan discharge damper, then PA fan A discharge damper, then air preheater in and outlet dampers, and then the hot air duct and the cold air duct is directly connected through the interconnecting dampers. So here you have to open the APH in and outlet dampers so that the circuit is made through and the air, primary air can pass through these and it can go to the cold air. The cold air damper for A mill has also been opened. Now when you give start command to the PA fan, A, suppose you have the PA fan A. So if you give the start command to PA fan A, you will see that the PA fan A discharge damper, will start opening when the PA fan reaches its rated speed. The damper will open, the interconnecting damper, that will also open, and the flow will be started through the cold air, cold air gate and then cold air damper, like that. And you can measure when you open the vanes of the PA fan A, you will be able to see the discharge pressure also. So similarly you can start the another PA fan also. So when you start the another PA fan, its discharge damper will open. Similarly the interconnecting damper will also open, and the air flow will now be through the aerator B as well as the interconnecting dampers and into the cold air header as well as hot air header. So this way the PA flow will be established. Now when this PA flow is established, you have to maintain the PA header pressure to be around 800 millimeters of water column. So we will be continuously checking it on control desk whether the. So now let us start the simulator operations. So before that, please subscribe our channel Total Output Power Solutions, like, share and comment on this video. So we open the file and now here you see that we have started the LOP, lube oil pumps of aerator A and aerator B, pump number 1, and that has been put on auto. Now we stop the pump that is running pump. So we have stop the pump and you will see that on auto the another pump has picked up. So first of all we start one pump, then put it on auto, and then we trip the pump. We see that the second pump starts, that is the test. Then we put the seal air fan also, they put them on auto, so that whenever we start the PA fan, that seal air fan will start automatically. Now we go to the this is the seal air fan. This is the circuit of the cold air and hot air dampers. You see here from cold air duct, the dampers will have to be opened for A, coal mill A. We are opening the gates first of all. So these are the cold air gates, those are being opened. Now you can open all the gates, cold air gates, for the mills you can take in service. If the mill is under maintenance, you will have to keep the gate closed. So we have got A, B, C, D mills available. So we open the cold air gates of all these A, B, C, D mills, and cold air damper for A, we open it around some open, maybe around 100% we have opened it, so that if the PA fan is started, the flow will be established. Now after this, we come to the PA fan A and B. You see that pre-check is there. PA fan A pre-check is there because the selector switch is on A. We check up the discharge pressure controller also. It is showing 800. So that is okay, or you can reduce it if you want to, or make it more, but it is 800. We want it as 800. Then the the vanes we check up. The vanes are also on 0, minimum position. Regulating damper is on minimum position. Then we check up the discharge damper, it is on interlock. We check up the interconnecting damper also, that is also on interlock. Interconnecting damper is on interlock, and that is closed. Now we can give the start command to PA fan, as the PA fan pre-check is also there. We have to manually open the air preheater inlet and outlet dampers. So we go to field page number 2, and from there we open these inlet and outlet dampers for primary air of the air heater for the primary air. So we have opened these dampers, and now you see you have got a pre-check for fan A. So you can start fan A. You can see that the selection is also on A, so the pre-check is there. Now we have started the fan A. Now you can see that there is a starting kick, and then it comes to normal. Starting kick goes up to around 600 amperes, and the normal amperes, when they come to normal, then the dampers will also open when it comes to normal. So now it is 60. So you can start the other PA fan also. You can start the other PA fan, take the selector switch on B and start the B PA fan. So you have started the B PA fan also, PA fan B, and its amperes are also coming to normal. Now when they come to normal, you can see the seal air fans, they have also started, seal air fan A and seal air fan B. If you want, you can make one of the seal air fans off, or maybe both the seal air fans can be running. Then you can check up with the dampers. The interconnecting damper is open, the discharge dampers, they are also open. Then the PA header pressure, discharge pressure is 800 millimeters of water column, set point is 800 millimeters. We slightly open the regulating vane, regulating damper, slightly open the regulating damper of both these, and we see that the some PA flow is established. You can see that some PA flow will be established. So PA header pressure is slightly increasing. You see 9, 10, 11 like that, and some actually the flow is not still not there, because it is only a building of the header pressure. So this is the header pressure that is being built up. It is now 53, 62, then 60 like that. We increase this still further, slowly we increase, and slowly we increase this header pressure. Then when we increase this header pressure, we will keep it in mind that the flow is very little, or maybe whatever is the leakage, maybe we have opened the cold air damper also. So through the mill, maybe the cold air is passing only through the feeder, through the coal mill, only the cold air is passing, but the mill is not running. Hence the very little amount of flow is there. Now you can see that the header pressure has reached to 326, 337 like that, and slowly once it is 800, we put this on auto. So let it still increase further. Till that time we will see the other parameters also, the common parameters, the level and all this drum level and all this, whether they are being maintained or not. So common plant parameters we can see. Here this is the primary air to mills. We have got 4 mills A, B, C, D and E. Their cold air gates open, and only one cold air damper of coal mill A is full open. Now it is reaching 800. So you see, when it reaches to around 800, we put this on auto, and because there is no airflow or the airflow is very less, the dampers they will close and still the pressure will be maintained there. So the pressure is now is around 855 or so. So when we take the coal mill in service, there will be some. So with this, I think it is the, now we have put it on auto. Well, thanks. So friends, here in this video we have achieved the PA header pressure, and we will be taking the coal mills in service in our next video. Till then, you can join our simulator training courses at Balewadi, Pune. The course name is 210 megawatt PC based simulator training for engineers or for students. The course duration is for 5 days, 2 hours each day. For future details, you may please contact Manohar Tatwavadi, mobile number 937-216-7165 at 82806 Palladion, Balewadi, Pune. So thanks for watching. Please comment, like, subscribe and share Total Output Power Solutions. Thanks again from Manohar Tatwavadi, Palladion, Balewadi, Pune.